For Linkerd. I work at Buoyant. I am joined by Ivan, also from Buoyant. He gets the hard job of actually making things work for customers and things like that. Uh, Ivan, you want to introduce yourself before we start talking about debugging Linkerd?
Sure. Sure. So, hi everybody, my name is Ivan Porta. I'm a customer escalation engineer at Buoyant. And yeah, today we're gonna dig more into Linkerd and see many ways to break it.
Excellent. Um, and Ivan, I believe that your slides will tell everybody where to go to see the demos that you're working with, which will be good.
Yes.
Um, I will put up some stuff about where to find more information for Service Mesh Academy and the like. But immediately, why don't you go ahead and start in with
Sure.
the demo, or start in with the slides rather.
Yes, we're gonna start with a little bit of theory. So let me see if you took. Let me start from the beginning. Okay. So Linkerd troubleshooting checklist. So sooner or later, something will start going south, we start having problem, but independently from Linkerd service mesh might be something related to your cluster. And also I want to highlight that, yes. A lot of times, actually that's very interesting, when there are problems, because Linkerd is like is sort of man in the middle between the applications, another application, control plane, everything. So it actually is making transpire a lot of errors. And the first thing that people think, that's Linkerd. But a lot of times it's not Linkerd itself, might be networking latency, might be the application itself. So it's important to have to know some commands to start troubleshooting, to do a sort of general checklist, or general check of the mesh.
One thing you said there is actually really interesting, and I think it's worth emphasizing that Linkerd tends to reveal errors more than it tends to cause errors. We've seen a lot of situations where people will install Linkerd and then immediately come back and go, this broke my application, horrible things are going on. And then you poke through and realize, no, actually, your application has been failing all this time. You just didn't have a tool in place to let you see it. So,
absolutely.
Yeah, that's a big deal, and that's going to be worth bearing in mind as we go through this.
Yes, yes. Actually, I think it's also make it easy because we have a lot of logs on layer 4, layer 7. It makes it easy to troubleshoot what's actually going on. Because you get a lot of information that then you can connect to each other to have a general picture all over the components.
Yeah, which is a big deal. I'm going to take one more moment here. The workshops channel on our Slack is the best way to jump in with questions during this presentation if you have any. Go to slack.linkerd.io, join the workshops channel. We'll be paying attention to questions there. Off we go.
So, there are several commands that I want to highlight today. The first one is about the logs, because by default, when we install Linkerd, we set the verbosity of the logs to info, which means you show a lot of information in the logs. However, because this value is set, basically is static, kind of static. If something happens, you need to change the log level. Let's say a lot of people tend to change in the Helm chart values or add annotation to make it more verbose, but that will imply a restart of the pod. But there is another way to increase the verbosity or even decrease the verbosity, depending on what you want to do, which is basically an endpoint with the proxy expose on port 4191, which is proxy log level, you can see at the bottom. And you can do a lot of things. First of all, you can increase the verbosity of the global level of verbosity. You can see, for example, on the blue warning. But then let's say you want to troubleshoot the load balancing. You can troubleshoot the output flow of the proxy. You can use these Rust modules and increase only those Rust modules verbosity. So we're going to see later in the demo that we are going to troubleshoot a particular flow in the proxy. We're going to increase the verbosity only of that part, and that will reduce the all the logs available and make it easy to troubleshoot. And
And if I
the most
recall
important
correctly,
part is
4191 is not exposed by default, so you have to port forward that or something along those lines, right?
yes, correct. And one very important thing is you don't have to restart the proxy. You port forward 4191, you send a curl with the basically string with all these parameters, and you change the log level on the fly. So that makes it's very important. The second are the metrics, because the proxy exposes a lot of metrics on the matrix endpoint. Again, you need to port forward 4191 and then send a curl to the matrix endpoint. And then you're going to get a lot of metrics in Prometheus format. And those metrics are going to be about layer 7 with total amount of requests, responses, the latency. We have a lot of buckets about latency. When we are going to have the output routes for the HTTP, gRPC, but also layer 4 with the TCP connection open, close, read, write, and also the control plane. So we're going to see about the endpoints for the control plane. We're going to see the certificate expirations. We're going to see the adaptive endpoints, which is more about balancing. So we're going to get all this information from the matrix. And that's something that during a troubleshooting session comes very handy. But now let's dive into the tools that we can use to do that. The first one is the Linkerd CLI, because it's a very powerful tool, because have a lot of sub-modules we can use to do a lot of things. But first of all, if something is not working, or you want to check the general health of the mesh, you can just simply use a single command, which is Linkerd check, and that will check a lot of things. We'll check the trust anchor validity, the webhooks, the identity, issuer validity. We'll check the control plane. We'll check all the roles if exist or there is something missing. We'll check if you have extension, it will automatically identify those extensions and perform checks for those specific extensions. Like for example, if you're using Linkerd multi-cluster, it will identify Linkerd multi-cluster that is installed on the class that is installed, and then performs specific checks for the Linkerd multi-cluster extension. So it's very useful to do a general check of the entire mesh. The second is Linkerd diagnose.
Linkerd check exposes a number of things. If kind of to the point where if Linkerd check is not passing, then that by itself is an indication that something is wrong that needs to be fixed first.
Absolutely. Before digging into logs, metrics, certificates, I highly recommend to run Linkerd check. So you can exclude a lot of possible causes and then start like excluding possible causes, like reducing the scope of the troubleshooting. And then we have a subcommand in the Linkerd CLI, which is the diagnostic. And that's very useful because it exposes several commands like endpoints, policy profile, and proxy endpoints, proxy matrix, which, as you might remember, earlier we mentioned to port forward port 4191 and then send a curl to the matrix endpoint. Well, you can just simply use the Linkerd diagnostic proxy matrix command, and then that will expose the proxy matrix of the pod that you specified. So just run the command, and you need to port forwards and curl, nothing. You just get the matrix with a single command. So that saves some time. Then we have the endpoints, which basically return the endpoints that the proxy that you specified is actually seeing. Policy is very useful. Policy is very useful when you're troubleshooting, for example, HTTP routes or traffic splitting. We're going to see that later. And then controller matrix, which is more about the control plane. So if you're troubleshooting something that is happening with the control plane, just run controller matrix, and then you get information specific for the control plane. But let's move on with something about the network policies, like a possible problem with network policies. So before we dig into the scenario, I want to get just a little bit of theory. So when you install Linkerd, you have two modalities. The first one is with the proxy init, and the second is with the Linkerd CNI extension. When you install Linkerd with the proxy init, basically it will install a proxy init container whose job is to update the NFT or legacy tables, depending which model you're using. By default, we have NFT tables. And then configure the root tables so that all the inbound connections are going to go to port 4143 of the proxy. And the outbound is going to be to 4140. So the proxy, basically, everything is going to go through the proxy before reaching the application, which is then going to be reached by a loopback.
And pretty much all the meshes have to do this sort of black magic with networking. It's one of the creepier bits under the hood that you see when you go looking down here.
Yes. And one thing that why should you use proxy init or Linkerd CNI? That depends on your environment. Some users might not have limitation on the capabilities, so they can have the proxy init, which require capnet admin and capnet row, which are the capabilities needed to change the root tables of the pod. Other environments might be more like not secure, but they might not
Limited?
want to allow this. Yeah, makes sense.
I mean, like, there are several cluster setups that don't give you these permissions just as a matter of course. I think OpenShift comes immediately to mind, where you're just not going to have capnet admin and capnet raw.
No. Good point, yes. So let's say you're installing Linkerd on OpenShift. Easy way to install it is to use Linkerd CNI, which you won't have the proxy init anymore. You have the Linkerd CNI that will, is not a CNI itself, will still require a CNI plugin behind the scenes. But what it does is create the Linkerd CNI conf list, which is appended to the existing CNI configuration, so that when the proxy starts, the CNI does its job, and Linkerd appends its rules. So it does the same thing as the proxy init, but using a CNI.
Which do y'all recommend to customers these days? Proxy init if they can use it, CNI if they can't, or?
Yes, like the default installation use the proxy init. A lot of customers don't have like requirements, that compliance, that they need to not expose those capabilities, so they just install Linkerd like with the proxy init.
I mean, from my perspective, proxy init is simpler. The CNI API, to the extent that it has an API, can be kind of weird to work with. And when it works beautifully. And when it doesn't work, it can cause some really subtle, tricky to debug failures. So I personally kind of like proxy init for its simplicity, given the option. Sometimes you don't have the option. So, you know.
Yes. Also, like if you're using the CNI extension, as I mentioned, there is a CNI plugin behind the scenes. So you need to be careful with the skip the services and route the traffic to the pod, and that creates some conflict. So you need to be proxy init much easier, let's say. And one thing that I want to highlight is Buoyant engineers, they did a lot of work with this level of networking, and into it is a feature like protocol declaration, where you can define the protocol in the service, and that will be honored by the proxy. basically all the communication in inbound between meshed pods will go through 4143. Before was using destination port, but now is from 218, the communication between proxies is just on 4143, and that's very important.
There's a way, I don't remember what it is exactly, but there is a way you can switch that off still, if I remember.
There was a annotation, but to be fair, I don't remember. I need to double check.
Yeah, it's in the docs. There are a couple of applications I've run across that get unhappy if they get redirected over port 4143. I think we're gonna have to take a note to look up which ones those were. Kafka's coming
Sure.
to mind, but I'm gonna have to check that one. Yeah.
So now that you have a general overview of all the moving parts, let's move to the problem. So let's say you're using Cilium or network policies, and you block everything. It's very common that people tend to block everything and use network policies only to allow specific ports between specific applications. So let's say that you blocked everything, and then you allow the client and server to talk only on port 8080 for inbound. 8080 is the pod in this case, on the left, we have the server. The 8080 is the port used by the application. So you might say, okay, perfect, 8080, I exposing port 4080, allowing connection on port 8080, so that should work. That's not the case. So the client on the right try to connect to the server on port 4143, which is the inbound for the proxy, but she is blocked by the network policy. So you start seeing a lot of requests by the client and nothing arriving in the server. And you start seeing like FailFast, you don't understand why I'm sending the request. So that's definitely, if you start seeing FailFast and nothing coming into the proxy and you have like network policies in place, that's the first place where I will check if you're allowing 4143. But we're going to have an example later with Cilium. I can't wait to go into it.
Not to say that we think Cilium is terrible, just it's a common place where people like to install network policies that can break this is all.
Yes. Also, I want to highlight that Cilium network policies are not network policies, are two different resources. It happened once that we had a customer that was in network policies, and we checked the network policies, they were fine, but also we had Cilium network policies, and that was a problem that was blocking everything.
Yeah, I was about to say, you can also confuse your world even more by having both of them, if I remember. So, yeah.
Yes. So that's for network policies. Let's talk a little bit about protocol detection. So when two proxies talk to each other, let's start from a thing, like you have an application, the application talk to the other servers using a protocol. It can be HTTP1, gRPC, or something else, like could be like could be Kafka, remember, could be like Mint, not Mint, don't remember. There are a lot of different protocols. So the proxy can't use all of them. So is focusing on layer 4 and layer 7. So when the proxy receives an inbound request, we'll need to detect the protocol. We need to understand, okay, this is HTTP1, HTTP2, or something else. This is because...
I'm sorry, the proxy knows how to deal with raw TCP. It knows special things about HTTP1 and HTTP2. gRPC is handled by the HTTP2 case, but
yes.
You know, if you have a connection that's actually gRPC and you try to treat it as if it's HTTP1, you're going to have a bad time, right? So
yes,
you kind of have the choice when you're building a service mesh of either requiring everybody to tell you ahead of time what all the protocols are or detecting it. And it's a lot easier on the users to detect it. So that's the way we went with Linkerd, where we can. Sometimes we can't, which is the the really important caveat there, right?
Yes. Actually, we are doing protocol detection in two parts, like in outbound on the left, for example, when there is application sending something in outbound, we go through the outbound flow. And that's mostly used by the proxy to understand, okay, the request that is trying to go out is HTTP1, so I need to wrap it up in a HTTP2 because the proxy talk over HTTP2.
Mm-hmm.
If it's HTTP2, it doesn't need to wrap it up, so just encrypt with mTLS and send it out. If it's something else, well, that's a different thing. It doesn't know what it is. So you try to read the first byte to understand, okay, is HP1, HP2, and then you try to understand what is the other, what protocol is that connection. But the problem is it can do it forever. And this is why we set a timeout. It will try to understand the protocol up to 10 seconds. Otherwise, we'll give up and treat it as TCP.
Yeah.
So
it's also really important because if you, for example, if you have an HTTP connection and you don't know it's HTTP, but you'll end up treating it as raw TCP, that always works. But it means that you can't provide any HTTP metrics and you can't do HTTP routing or HTTP authentication or any of that stuff. So it's a big deal to get wrong.
Yes, absolutely. And so basically we are doing this in outbound, but also in inbound, because when the proxy receives the connection, the package, it doesn't know if it needs to send the application. So it doesn't know if it's HTTP1, HTTP2, so we need to recreate the unwrap, let's say, the HTTP2 in the correct protocol. So that's another protocol detection that it does. One thing that I want to highlight is in server speak first, like SMTP or MySQL, or there was another one which I don't remember now, which is not Nint, or I don't remember. I'll think about that later. But all these server speak first protocol.
The biggest one that I run across these days is actually NATs.
Yes, NATs. Yes.
People like to, it's a simple sort of pub sub thing, and it's server speak first.
Yes.
Which, back in the day, we all liked server speaks first protocols because they make your life easier if you're a human trying to connect over telnet to debug what's going on with the protocol, right? Which we kind of don't really do anymore. And it's been really interesting in the cloud native world to realize that server speaks first protocols are really, really bad for containerized environments, right? They cause so much, because it's so much easier to route client speaks first protocols, and we can do so much better for reliability and performance and all that stuff. So those of you who are listening to this, who are protocol developers, client speaks first. Yeah, just design everything that way. That's the right way to do it from now on.
Or we are gonna pack your port because that's the only thing we can do.
Yeah, I mean it's really hard. Yeah.
Yes, and in fact, in those particular protocols, there isn't much we can do because, as I mentioned, the proxy will try to read the first bytes of the requests to understand the protocol. But because the server speak first is not sending anything, we don't know. We just stay there waiting for those bytes to arrive. And this is why it's very important to mark those the ports of those protocols as opaque. So we are not expecting anything and treating them as TCP. We're still encrypting them, but treating the content as TCP, don't do any protocol detection. So this is the overall in protocol detection. And this is one thing that I want to highlight is you're not going to see protocol detection timeout in both client and server proxies. You're going to see only one, because if the protocol detects, there is a protocol detection timeout in the client, it will automatically be smart. The client proxy will be smart enough to tell to the server to treat it as opaque. So you will just see only one protocol detection timeout.
And
And
obviously
now
you can
traffic.
mark things as opaque yourself, as the last thing on that slide mentioned. You can mark it as opaque on your own, and then you skip the whole thing. And
Yes,
if you
yes,
do protocol declaration, you also get to skip the whole thing too, right?
yes. You can define the protocol in the service.
Yeah.
Tell you, okay, perfect. This service is this protocol, and the proxy will automatically know that and will skip the protocol detection. Will just simply wrap it up, unwrap the connection on that particular protocol.
Yeah.
Now, traffic. Traffic, sounds scary, but it's more about how traffic is managed. So let's talk about a little bit of theory about the traffic. So when you have a proxy start, the destination controller is the component of the control plane which takes care of um, service discovery. It has two particular methods. One is get and get profile. And get is the one that basically the proxy start and subscribe to those two endpoints of the destination. Destination then start watching like nodes, pods, services, and point slices, everything, and index that in an internal cache, so that everything is very easy to process. And then provide updates to the subscribers, which are all the proxies. So we can also monitor these two methods in Grafana, which is very useful if you want to troubleshoot the control plane. But going back to the flow, the proxy needs to send a request. He already subscribed to the get, so we already have everything that he knows, and then send the request outside. So these are the core components: the destination, the subscription to these particular endpoints, that will then provide all the updates related to particular endpoints and everything else. So let's say that your cluster, you have the client server, and somehow you start seeing connection timeout. There is particular error which is connection timeout. You're gonna see that in the logs. I don't know where it's coming from and what's the cause of that. And then after some connection timeout, you start seeing FailFast. And that's especially with HTTP, you start seeing FailFast rather than connection timeout, but that's another story. So you don't know where it's coming from. Like, why is failing? And you start checking the logs, connection timeout, well, something is blocking, you don't have network policies there, so what could it be? So the connection timeout is a particular error, which is related to the connection when the client trying to establish a TLS handshake with this server, it waits for a particular amount of time, which is by default 1 second. If your network has some latency, like could be a lot of different causes, so it's very slow to establish this connection, this TLS handshake, actually more like getting a response, then it closes the connection. It closes the connection once, twice, 3 times, and then start marking that endpoint as an IP. But what is important is, in this case, as we said at the beginning, Linkerd is not the problem, it's just highlighting another problem, which is, in this case, the network. So we're getting this timeout, and one thing that you can do is, let's say, is a production cluster. It's like, nothing is working, everything is done because of the network. One thing that you can do is, okay, by default is 1 second. If you want to have some breathing room to start troubleshooting the issue, you can temporarily increase this timeout using annotation. You can bump it up from 1 second to 2 seconds. I highly recommend not to leave it there, because if it takes longer than 5 seconds to connect, that's definitely a problem. But if you want to have things working while you troubleshoot the underlying problem with the networking, you can increase this timeout using the annotation.
Even 1 second is a really long time in a cluster, but yeah,
Yes.
You may need more than that to take a look at what's going on.
Absolutely, yes. Now let's move to another problem. Let's say that your application, you release a new version of your application. Your application start going in crashback. The proxy is up and running, but your new version is starting going crashback loop, crashback loop, crashback loop, crashback loop. So you start seeing some messages in the client with gateway timeout.
I think that's crash loop back off, right?
Yes, crashback loop off.
Just-
Yes. Sorry, I made
Just
I made
making
a
sure we're
typo.
talking about the same thing, right? It's like, oh, wait, is this
Yes.
right? Another thing is I've had people ask me before what exactly FailFast means from Linkerd. So what's your explanation of the meaning of FailFast while we're here?
I would say that FailFast is he tried to connect to the server multiple times, and then if we can connect for different reasons, he going fail fast.
Yeah, at one point I understood exactly what was going on in the proxy, and I might be wrong about this now, but I think that you mentioned the destination controller keeping track of endpoints for services. And
Yes.
I believe that a fail fast technically means that the proxy has decided that the thing you're trying to talk to doesn't have any valid endpoints. So it has nothing to try to
Okay.
connect to, and so it's just rejecting it. And then you come out of fail fast when the destination controller gives you some endpoints that are things you can really talk to.
Yes.
So it's all right. While you go on with this, I'm going to see if I can find the document where we talked about this, because it was pretty interesting, and it shed a lot of light on what you should be looking for when these things start screaming about fail fast.
Yes. Actually, if you start seeing fail fast, like the first thing that I will check is actually the server healthy? Is everything working there? Because it happened a couple
Yeah,
of times that
absolutely.
the service was down, was in crashback loop off. So like we are getting this error in the client, and we're troubleshooting the client, but the problem was something else, was actually the application, which was not up and running. Or we can get it from, like for example, what you're talking about earlier, like network latency, try again, try, and they start going very fast as well. So I would say that a gateway timeout or fail fast in general are more about the server not be available for some reasons.
Yep. I think once or twice I've seen it where the workload was available, but something had changed, like I'd accidentally broken the label selector on a service or something like that. So the workload was there, but I was trying to talk to a service that wasn't connected to that workload anymore. And it ended up in FailFast because there were no endpoints behind the service because I'd given it a wrong label selector. So
Yes.
that took a little longer to figure out than I would care to admit to.
Yes. And that's actually the example that you just mentioned when the server is not there anymore. You scale this, for example, if you scale the replicas to 0
Oh
and you try
yeah,
to
that
send a
would,
request,
yeah, that too.
it's not gonna be there.
I mean, a lot of what we're getting to here really is saying that Kubernetes network plumbing is interesting in a lot of cases. And so when you think about it, to make things work correctly, you have to have created a service. You have to point Linkerd to a service. You have to then make sure that that service has label selectors that correctly attach to some pods that have valid endpoints because they're actually running and they're actually healthy. So there are a lot of different steps that can go wrong here. FailFast is very much a symptom of, this FailFast is Linkerd telling you something in that plumbing that I just described is wrong. Maybe it's that you don't have any running pods. Maybe it's that you didn't, you changed your health probes so that they're no longer correct and Kubernetes thinks that they're not ready. Maybe somebody edited the label selector on a service. A new, particularly fun one these days is you can use a service with no label selector at all, but that you have attached an HTTP route to, and that will work. It's
Okay.
that's using only the front end piece of the service, so you can direct traffic to it, and then the HTTP route has to direct it to something else. Um, but it's just another way in which the plumbing can break in fascinating ways. So yeah, the lesson for all of this is FailFast is an indication that something is going wrong elsewhere, not I don't think I've ever seen it be a problem with Linkerd as opposed to a
No,
problem with the plumbing underneath it.
no, I agree. I agree. And the next one, that's actually pretty interesting. So if you start seeing service unavailable, what do you think? The first guess is there are no
Um,
endpoints.
yeah, I'm cheating because I found the common errors page that talks about this, so I should not answer.
Okay. So let's say that you start seeing service unavailable with the status code of 503, for example. Like the first thing that a lot of people think is there are no endpoints. But one of the possible cases is there is actually the application. So everything is working fine, and the 503, for example, in this case, is coming from the application. So the application is returning 503, and the proxy is actually returning that to the client. So the 503 is not coming from the proxy, it's coming from the application. And when you know that is not a Linkerd problem, it's not a Linkerd error, in the header. If there is a problem with Linkerd will populate the L5D proxy error with something. If it's not there, it means that it's not Linkerd. It means that it's returning a status code from the application. And that's why we say 503. Now, we cover like a lot of things. I think we have a couple of topics left. One of these is routing. So, okay, like in the past, service
Let me,
profile
uh,
were very.
let me jump in for one moment. The link at the bottom there, Docs Common Errors, is the page that describes FailFast and some subtleties about 502s and 503s and 504s. But as I was trying to say while I was muted, I did not know that bit about L5D proxy error not being set when it was coming from the application. That's really handy to know. Thank you.
Yes. Actually, we're gonna see later in the demo. Like we're gonna see plenty of header that is gonna help us in finding the error.
I learned something. This is awesome.
So let's say like you've been using Linkerd Service Mesh since 2.1. So you've been using service profile a lot to route the traffic. And one day you decide, okay, I wanna migrate to HTTP routes. So you move to HTTP routes, and you delete the service profile. But instead of saying 100%, for example, of the connection going to the canary, you still see some connection going to the primary. So it's not matching the way the traffic is routed to the servers. It is not matching the HTTP routes. Why? That's because when the proxy starts and need to send a request in outbound, and there is a service profile attached to the particular identity, it will flip, let's say, will toggle a switch that, okay, perfect, this is a service profile, I'm gonna monitor this service profile. Just look for destination overrides in order to route traffic for that particular identity. We are gonna see later using the Linkerd diagnostic profile, how can we see that? The problem though is it is not gonna keep that, it's not gonna look for the service profile forever. If there is a cache, so once the cache is invalidated, it can start routing the traffic based on the HTTP routes. But if, for example, if you have an environment which there is a lot of load, you might never invalidate that cache. So the way to solve this routing mismatch when you migrate from service profile to HTTP routes is actually to restart the pod. When you restart the pod and the service profile is not there anymore, the proxy will honor the HTTP routes traffic split. But if the service profile is still there, it will take priority. So think about that. If you have a service profile and HTTP routes, service profile will always win. If you have a service profile,
that was a deliberate choice when we started doing Gateway API for routing, because it's a way of arranging it such that you can't have a production situation where somebody puts in an HTTP route that they shouldn't have and suddenly takes over from an existing service profile.
Yep. Do you think it's also something about security that someone can just simply deploy something and route to?
I mean, you could redeploy the service profile probably if you had that kind of permission anyway. So I think it's more just trying to obey the principle of least surprise, right? If you have a service profile, then we keep doing the service profile thing, and you have to actually delete the service profile to indicate that no, you really want to be using the new world now.
Makes sense, yeah. But you need to restart. You need to restart the pod or invalidate the cache.
Yeah, I mean, that's, I get it. I understand why the implementation was done that way. It might have been nice if we had not required that, but the flip side of that one is, being a little more serious for a moment, it's relatively rare that you're going to be going back and forth between service profiles and HTTP routes, and then back to service profiles, and then back to HTTP routes, right? This is the sort of thing where what you want to do is get rid of the service profiles in development once, restart everything, recreate all your HTTP, create the HTTP routes that will give you the functionality you had with service profile, and don't do any of that in production until you've demonstrated everything working in in development. And then you can just go and in one fell swoop, you delete the service profiles, you apply all the HTTP routes, everything is still working at this point because of the way the proxies are going, and then you restart and you come up and everything is great, right? That's the goal. If you find yourself moving back and forth between HTTP routes and service profiles in production, that may be a signal that you should reevaluate your life choices.
Also, if you don't know, like if you start now and decide which one should I use, I highly recommend to use HTTP routes because they have like header manipulation, they have a lot of different features that will make your life much easier, especially now with ingresses and everything. But
path-based routing all by itself is pretty much worth the price of admission there, right?
Yes.
Yeah.
Yeah, now we move towards certificates.
Our favorite things.
Yes. So today we're actually going to talk about some certificates that are left. Not on the we don't talk about them that much, but they're there. So when Linkerd basically have three different, two validating webhooks and one mutating webhook. The difference is just validating the policy or specific configurations before accepting or rejecting them, while the mutating is actually performing some changes to the actual request. Like for example, let's focus on the proxy injector. When there is a create a request to the Kubernetes API will basically process all the mutated webhooks in order that match specific selectors. And when you reach the Linkerd proxy injector mutating webhooks, then that will call the proxy injector controller that will do some stuff. In this case, inject the proxy. if there is a specific annotation, which means we'll append the proxy to the request before sending back to the Kubernetes API, and then we schedule the pod with the proxy. Now, in order to talk
Webhooks
to
are
the
so much
Kubernetes,
fun.
yes. There was a talk about removing them, but I don't know.
I think
They're
that would be
kind
a
of-
mistake too. It's webhooks are awful, except for the fact that there are things that they can do that nothing else can do. So
True.
yeah, it's tricky and weird.
And to be fair, there are a lot of projects that are they're actually based on webhooks, like for example, Kyverno.
Yeah,
Kyverno
yeah.
is 100% webhooks.
Most of the
Yeah.
most of the policy enforcement engines lean really heavily on webhooks. Now that we have validating admission policies in pretty widely deployed Kubernetes versions, it's a little less critical, I think. But there's validation you can do in a webhook that you can't do in Cell, which is one of the interesting challenges there. And I know that there's some discussion of doing mutating webhooks based on, doing mutations based on Cell without using webhooks.
Oh.
And
Okay.
that to me is interesting. It'll be interesting to see how that really works out, right? It's hard to see how you do the proxy injector with Cell, right? I can think of ways you extend what Cell can do to make that possible, but yeah, I don't know. It's interesting.
We have the logic of the proxy injector is simple, but not that simple. There are a lot of checks we're actually doing, before injecting all the configuration, environment variables, a lot of things. Even the certificates, need to read the certificates, inject and everything.
Yeah, there's a bunch of really interesting stuff to look at before we get rid of mutating webhooks.
Yes. Is a necessary evil so far?
I'm sorry, say again?
Is a necessary evil? How do you say it? Like that?
So far, they are very definitely necessary evils.
Evil.
Unless you think, it's possible to use Linkerd without using the proxy injector, right? You can do everything using the Linkerd inject command. You can put the YAML for the proxies in and have it managed by GitOps. You don't need the proxy injector, but it really makes life dramatically simpler to use the proxy injector. At some point, we might want to take a look at redoing our validators with Cell. I don't actually know. I know that's not possible with the functionality they currently have and the functionality Cell currently has, but it's an interesting idea for sure. The gap there is that the validating webhooks can look at annotations, and validating annotations in Cell is either weird or impossible. I don't remember which. So, but we might be able to fix that, right?
Yeah, well, there's been a lot of work going on there, so who knows? Maybe in 5 major version from now, who knows? Well, going back to our webhooks. So in order to talk to the Kubernetes API, those webhooks need a certificate for the TLS because the connection between these webhooks and the Kubernetes API is not in plain text. So we have these certificates. When you install Linkerd using Helm or the Linkerd CLI command, it will generate a self-signed certificate with a validity of 365 days. That is we're going to use for the CA bundle of those webhook certificates that then is going to be used to the Kubernetes API. So that's there. But let's say that you don't have Cert Manager or any other tool to rotate those certificates. They're going to expire and you don't upgrade Linkerd for a year, which is pretty bad, but it happened. So what's going to happen is those certificates are going to expire. They're not going to take down anything because those are webhooks. Those are not affecting the actual proxy pods. They're going to be there. They're going to be working. The problem though is if you have, for example, the proxy injector validating webhook CA bundle expire, the next create request to create a pod with the proxy will go through the webhook. That will fail. And then the proxy will come up without the proxy. So it's not going to inject the proxy because it failed because of the certificate. There is a important configuration in the, I think is in the next slide. Let me double check. Yes, here. So there is important configuration in validating webhook, which is failure policy. By default, it's set to ignore, which means, for example, in this case, if the certificate is expired, it will not block the creation of the pod. It will just simply skip it. We just simply skip the injection of the proxy. So the pod comes up without the proxy. And so one thing that, as I mentioned, is to use Cert Manager. Cert Manager is very useful in this case because differently from the trust root, the certificate, you can rotate them and they're going to be updated. You need a specific configuration, but you can rotate them without creating bundles and all these tricks, let's say. Yeah. So it's pretty easy and make your life easier. You don't need to create alerts or sort of reminders to rotate your certificate. So if you can, use Cert Manager. It will make your life easier.
A question I've gotten a couple of times is, oh, but can I have my webhook certificates be generated from the trust anchor? You shouldn't. It'll work if you do, but they're very different. They have very different purposes, and their purposes are sufficiently different that I would recommend not doing that. If you want to have them be generated from some trust anchor, some other certifying authority, instead of being self-signed, yeah, fine, knock yourself out. But basing them on the trust anchor that's used for workloaded entities, I would tend to recommend not doing that.
In fact, in our guide, we mentioned to use to generate a different CA for the webhooks.
Yep. And I don't remember what you set webhook failure policy to, other than ignore.
There is fail.
Yeah, I was going to say, you can change that so that if the certs expire, you will get a much louder error. That's kind of up to you. Another way you can do this is if you run Linkerd in HA mode, which I would certainly recommend, then it will notice and complain if a pod tries to come up without a proxy. Although, to be candid, I don't remember if that relies on a webhook or if that's something else that happens. I feel like it has to rely on a webhook, but
I think so. And to double check. Yeah. That's a good point. Yeah. So,
but yeah, I don't want to stand between you and the demo. So that goes to the playground, right?
Yes. Basically, we created a project called Playground Laboratory, where, let me share this another slide. Where is it? Share. Oopsie. Screen and here. So is a Helm chart that you can deploy in your K3D environment, Minikube, or whatever it is, even if on AKS if you want. And basically what it does is just have a nice UI in Next.js to showcase some, like, where are the connections going. Latency, you can see here all the calls, like which version, survive. Basically, this is like getting some information from the actual response. What is interesting is the mTLS is based on the existence of the L5D headers. And we're gonna see, like, on the tutorials here is like what different things that we talk about today. The first one is how to set up the cluster with K3D and all the things you need to do, like from installing Linkerd, starting a new cluster with K3D, and then installing this application, which is the base for the tutorial. And then we have all the other examples that we mentioned during today's Service Mesh Academy episode. So I would say, let's start, since we talk about webhooks, let's start with the webhooks.
Go for it.
Let me share the terminal now. There we go.
Yeah, one of the things that's interesting about the playground to me is that if you look at Service Mesh Academy, a lot of what we demo with is faces and similar sorts of things where we're trying to demonstrate with a really simple application so that we can go through and it's easy to understand exactly what's going on, even if you are not really familiar with the application. The playground is more about, I guess I would say, being able to go deep into the weeds and cause very specific low-level failures. So it is a great resource as well, since these are the kinds of failures that we try to deliberately avoid in Service Mesh Academy. In the main Service Mesh Academy repo, we really tend to want to show you things with Linkerd working correctly, as opposed to showing you how things fail with stuff like this.
So let's start with the mutating webhook certificate. So let's see, mutate kubectl get mutating webhook. Now configuration. So we have the Linkerd mutating webhook, and let's take a look at what it looks like. So let's go here, this one, and the YAML. So we have the certificate, which is the CA bundle. I installed Linkerd this morning, so we still have 365 days. And what we can do is copy this one, and then echo this one, and then base 64 HD, and then we can use step certificate inspect, and then we can see here the expiration, which is basically 1 year. So that's the certificate we get with the installation. And one thing that is interesting is, by default, the failure policy is set to ignore. So, which means if something goes south, it's not going to block the creation of the pod. We're going to see that later. And then the service that it calls. So it's going to call the Linkerd proxy injector in the Linkerd namespace on port 4043. So that's basically the flow. Now, let's say, okay, perfect. We don't want to wait 1 year in this episode. I bet you like us. We can talk for a year about Linkerd, but that's going to be a long wait.
We'll need to take a couple of breaks.
So I have a command here to generate a certificate. You can see that in the playground laboratory. So this one is going to create a certificate which has a life expectancy of 2 minutes. After 2 minutes, this certificate is going to expire. And we're going to see that here. And if I do echo and this base 64, yeah, the certificate, which is 2 minutes. Now, let's patch the mutating webhook with this certificate. So we know that it's going to expire in 2 minutes. Now we just need to wait. Let's wait 2 minutes.
2 minutes is much more manageable, yeah.
Let's scale up one of the deployments. Now let's check the pods. Oh, something is wrong. As you can see, these are not injected. Something happened. It might be the certificate expired already. It might be wrong, or might be a wrong certificate. Something happened with the certificate. And as you can see, it's not blocking the creation of the pods. They're coming up, but they don't have the proxy.
Are they running now?
The same thing will happen. Yes,
yep.
Running, but
but not injected.
Exactly. So this happened.
Which,
Probably, I think the problem
sorry, go ahead. Do you think the problem
is the certificate not a wrong certificate rather than expired certificate, but the result is the same.
Yeah. What I was going to say is that one thing to remember there is that since those are not injected, that doesn't just mean that they aren't getting mTLS. It also means things like if they, for example, if you're relying on HTTP routes to manage communications coming out of those pods, suddenly that will stop working. If you're relying on HTTP authorization, or if you're relying on Linkerd to do authorization for those pods, that won't happen either, and anybody will be able to talk to them. So there's a lot of challenges that happen when this is going on.
Yes. And if you want to avoid any chance of these pods coming up if they're not injected, you can change the failure mode to fail, and they will not come up. You'll see the replica set in the desired state. You see desired 2 or 50 or whatever it is, and current 0.
Yep.
Now, let's...
That's kind of handy,
Let's
though. If
go
you
back.
generate a bad certificate, we didn't even have to wait 2 minutes. That was great.
Yes, well, the result is the same. Now let's get the pod, get pods.
So when you
and-
did Linkerd upgrade, I believe that the point of doing that was that it's going to regenerate their certificate, right?
Yes, correct. You can see here configured with a new 365 days valid certificate. So now if
Yeah.
I scale down, or actually let me scale up to 3, and I check the pods again, they're rejected.
Yep. But of course, we still have those 2 uninjected things going on, right?
Yes, they're still there.
So
So
hence why it can be important to get rid of those as well, right?
no, they're gone. I scale down to 1, and they're gone, both of them. Okay, so that's for the webhooks. How much time do you have? Just to have an idea of which demo to do.
We can do
next.
another, let's do another demo or 2, and then we can call it good after that.
Okay, so let's say, okay, I will keep the network policy at the end because you will need to install Cilium and restart a couple of things. So let's go with a FailFast. So now,
FailFast, always fun.
yes. So let's say the one you mentioned earlier, like, actually, let's do 2 FailFast. One with the error. So the first thing is we have the pod. Let's change let's upgrade. There is this application, the server has a lot of parameters that you can configure to simulate error, latency, and other things. In this case, the application, I'm gonna simulate the release of a version that has some problems. So 100% of the responses are gonna be with status code 503. Oops, 1 second. There we go. This one. Okay. So they're gonna be healthy. We just simulate some problem with the new release. So kubectl get pods, and they're up and running. Now, we can see if you go back. Actually, you can see if you look at the diagram or the homepage of the playground script, you're gonna see a lot of errors because now all the connection from the client are failing because the server is returning 503. And if you check the logs, 100% is returning 503. And now let's check the client, which is the interesting part. So to check the client, clear. We get the pod, and now we are gonna use a debug container because you can exec inside the proxy. So if you want to simulate a request in the same pod, you can use a debug container. So we're going to send a request to the server and check the 15 lines of the request in verbose, and that's where you're going to see some interesting stuff. So we can see here service unavailable, and we can see the client ID, which means because we see in the client ID, we know that the mesh is actually working. The problem though is something is going on, something is happening. We can see the header appended by the proxy, but we see 503. So what next? So we can check, we can use the Linkerd diagnostics, and in particular, tick, clear. We're gonna use Linkerd diagnostic to get the metrics of the client. And in particular, we're gonna filter for two particular metrics: the request total, the response total, and they are bound very fast. So we can see the response total. There are thousands of them here. Actually the canary. But what is important? There is a FailFast one, which is upbound. Should be somewhere here. We can see classification and success, classification and success. There are going to be some of them with failure, success. Yes, here we go. No, this is 4191. Success.
I think your failure is failing.
Oh, no, wait, here, I found it. It was the first one. So it's actually working, but we can see that the classification is failure because the status code is different than 200 or the success code. So we are seeing the header from the proxy. We can see, we see the status code 503. So starting from these two informations, the next step would be, okay, I suspect there is something going on with the server. So starting the bug in the actual application.
If you run that command again, do we see some of those outbound load balancer in FailFast? Outbound HTTP balancer in FailFast?
You mean the matrix?
Yeah.
Let me see. Let me just filter for those.
Sometimes I know it can take a little bit of time for it to catch up. Okay, well, that's interesting.
What should be there though? Huh? No, that's another one that should be there. Like we should see the bound basically as well. But in this case, even using the the response total, you can see that the classification and the code coming back. And also take a look from the headers. Those are very important in troubleshooting.
If you, what happens if you scale the endpoint or scale the replicas to 0 on that?
That's the next one. That's very interesting.
Oh, that's the next one. Sorry, jumping ahead.
No worries. So let's scale down both of them, because right now we have like the architecture of this application is we have canary and primary. Each one of them have their own service, but then there is a general service for both of them. And that's the one that we are using. So we have kubectl, scale, deploy, and then this one, replicas was 0. And then primary. Okay, now kubectl gets service. And now we're going to explain why I'm looking for the service in 1 second. So if you go here and we check for this particular service, we go with Linkerd, diagnostics, endpoints, and then we add this one, dot playground, .svc cluster .local. I don't remember if I need to add the port as well.
I think you do. I'm not sure.
And there we go. Oh,
Yeah.
so no endpoints. This is because we don't have any. These are actually the endpoints that are used by the proxy. And
Right.
no endpoints means there are no endpoints that the proxy can use. Now, let's check the logs of the clients. Actually, even better, let's send another request from the client so we can check the actual response. So same request to the same service. The error is going to be different. So get service unavailable and root service unavailable. But we can also get 504 FailFast. Let me actually get mCTL. Let me check the logs of the proxy. The pod. Set -n playground pod. Yeah, we can see a lot of service unavailable. And here we go. This is our FailFast. So, oops, enlarge a lot. Sorry. Okay. What you can see here is this FailFast. We can see the service that is trying to reach, and in this case, the FailFast would have been like 504 gateway. Don't
I
remember.
think it was a little bit more readable when your window was narrower, actually.
Ah, sorry. Oops. There we go.
Yeah. But yeah, so we ran out of endpoints and we entered FailFast.
Exactly. And
Actually, if you look up a little bit above that in your logs, you can actually see it. You know, removing endpoint.
Yes.
Yeah. Basically, nope, give it up now. You know.
Yes.
Yeah.
Yeah. Also, we can see here. This is interesting. The connection timeout that we talked about earlier. In this case, a lot of time is the network. I mean, not a lot of time is the network, but the network could be one of the factors. In this case, the timeout is because the actual server was being turned down by the kubelet. So start going down, it start not accepting connection. The TLS handshake started not to respond because actually was being terminated on the server side, so it got the timeout. And so I would say last one. Let's go with, let's try to install Cilium. We'll take a little bit because their pod.
Everybody keep your fingers crossed.
Yeah, there are 6 containers. It's gonna take a little bit.
To be clear, I'm saying everybody cross your fingers less because this is Cilium and more because I get nervous whenever we install CNIs. You know?
We can use Calico, will be the same.
Yeah, Calico, flannel, you know, you name it, right? I just get worried.
I don't remember. Do Flannel support network policies?
I don't actually remember. I have a weird personal relationship with network policy because I am very, very much a fan of the idea that security should not rely on network infrastructure. So to me, network policy is largely a way just to kind of add a little bit of reinforcement, you know, a little bit of, well, you know, since we're pretty sure we don't need this particular thing here, so let's just block that network path, right? But I have personally seen a lot of situations in which network firewalls or network policies ended up causing a lot of trouble, and you know, just because somebody would misconfigure them, or there'd be a case where the people who were running the firewall didn't realize that a particular network path was important, and so they would close it down, usually at 5 p.m. on a Friday, and then, you know, all sorts of crazy things would happen, you know. So I'm biased, right? I'm very, very biased towards if I don't control the network, I would rather just have the network be open and then rely on encryption and mTLS identity and things like that. But I want to be clear here. That is my bias. That does not mean that I think everybody should run out and immediately delete all their network policies, because used properly, used properly, they can definitely help with security. They are going to be a valuable layer. When you start talking about egress, they're actually a really important layer in there. So yeah, I think that they can be a very good tool when used properly. But I personally don't remember which CNIs implement them, because I tend to reach first for cryptographic identity.
So you need to get ready, like next time there is going to be a problem. Someone, I watched a SMA from Linkerd, they told me to delete the network policies, and now...
Yeah, please don't do that, people. Maybe I should post something in workshops just to make sure I am not telling people not to use network policy. You can use network policy if you're going to be careful about it. Right? Yeah.
So I think we are lucky here. I see some crash back, and let me see.
Yeah, we might need to burn the cluster down and recreate it, huh?
Yeah, I think so. So let's leave the network policy for another time, because this is going to take a little bit. I think 5 minutes to bring up everything. Yeah. One thing that you can do, on the other hand, is the protocol detection timeout. Okay, let's pick protocol detection timeout or the service profile.
Let's do protocol detection timeout.
Okay.
Just because that's the sort of thing where, like we said earlier, hopefully you're not going to be flipping back and forth between service profile and HTTP route a lot. But no matter what you do, you may very well have to worry about protocol detection on an ongoing basis. So let's talk about protocol detection and hopefully protocol declaration.
Okay. So let's change. One thing that we're going to do first is to increase the log level of the... Actually, why I have just one client? I don't have a server. 1 second. Interesting. I have just one client and I don't have a server anymore. Okay, let me burn down the cluster. Fed cluster list. Actually, I have another cluster just in case of emergency, so we can use that one. List kfred cluster delete. And let's delete this one, which is the one we're using. And then let's check this one. Should kubectl config use context playground. And now we should see something. No, nothing. Okay. Let me bring up the cluster back again. Wait, I wasn't using Playground Live, maybe? No.
The moral of the story here is don't try to install CNIs after your cluster has been running for a while.
Yes.
I think.
Okay, let me create a new cluster. Okay, delete cluster playground. No, sorry, it's cluster delete. And delete this one. Okay, that's gone. And now let's recreate it. So we can give an example of how to install Linkerd.
If it makes you feel any better, I have had to do this while on stage at KubeCon.
No pressure.
Yeah, I'm pretty sure that was the egress demo in Paris, I think it was. I'll have to go back and look, but yeah.
Wow.
So I'll point you at the video for that one, and you can watch my demo crash and burn until I blew away and restarted my cluster on stage. It it was fun. Yeah.
Amazing.
Yeah, I was demoing something that was very, very new, and earlier in the day I had installed a version of Linkerd that was a couple of weeks too old. So
Oh,
yeah.
wait, Paris. What year was it? Like 2021 earlier?
No, it was later than that.
Okay, so it's coming up. They're not meshed because I started the application before actually the proxy Linkerd, the proxy injector and everything was up. So I need to restart them after ring map and protocol declaration. So the first thing that I need to check is this one. Let me see if it's coming up. It's gonna take a little bit. The first one will be the identity to start, and then the rest. Usually the last one is the destination because is the core, as like.
Yeah.
And for different containers, which do a lot of work. The identity, proxy injector, where we are running, and let's give them a couple of minutes. Okay. Increase there, roll out, restart, deploy, and then play ground. Okay, and they're gonna be meshed now. Now, before doing anything, let's check what we have with a vanilla installation of Linkerd. Let's check what we have in this pod. Yeah, describe pod. So if you scroll up, you can see all the configuration of the pod. And one thing that is actually interesting that we're gonna change soon is this one, the proxy logs. So we can see is all for Linkerd related. These are all modules. Like these are Rust module for Linkerd, which I think is a module which we don't remember what we use for.
I feel like it's
engineering talking about that.
I feel like it's the log module itself, but let me find out.
So this is the general, this is module and module. So let's change them.
Oh no,
because we actually need to change it.
Hickory is apparently the DNS client and such.
Okay.
And now
So
we
we're
know.
showing errors with DNS. Yes.
Well, it's bad if you get DNS errors, right? So
Yes. Okay, so as you can see, I handle connection for 191. I send a curl, and I change one of the modules. Actually, I added one of them. So if you describe it now, you should see something different. No, it's the same. Change on the go. Sorry, these are environment variables. So these are not gonna change, but it's just gonna change for. I assume it's gonna keep it in memory for in the sort of take priority on the environment variable. I assume, but what we need is we change on the fly. And if I check the logs, we can see different things. So we can see detection, how long it's going to take to detect the protocol, in this case HP1, it just a second, so very, very little. Now.
2 microseconds, so slow.
Yes. Now, the next step, actually, because I'm following the way to recreate it to create a problem, which is, yes, so is this one. In the client, we are to create this problem actually was tricky because I needed to change the configuration for a specific user, because otherwise if you create a delay on the network layer, even the probes are gonna face that error. So in order to recreate this issue, I need to specify a particular user. Or I think adding a timeout as well. Let me see if I'm missing something. Oh, that should work as well. Yes, this is gonna work because we are not using HTTP. We are using basically netcap, which is not HTTP or gRPC or HTTP1. So, and also we added a timeout of 15 seconds because we want to see the timeout. So what's gonna happen is sending a request to the server, is using a netcap, which is not, is basically a TCP. And it's going to wait for 15 seconds. The way it's waiting 15 seconds is so we can actually see the timeout. It's taking longer than expected.
This is how you know we're doing it live.
Yes.
We're getting different failures than what we expect, you know?
Yeah, should I actually print something in output, like real the time, but yes, there it goes. So it took
15 seconds feels like
seconds.
a really long time when you're just waiting for it.
Yeah, just because we added a timeout as well. But this is actually what's something very interesting. Now we increase the logs. We increase the log level earlier. So we are just filtering for specific logs. And now we are filtering for detection and timeout. So these are the two lines that you care about. So you can see continuing after the timeout. And let's remove them so we can see the logs in all logs. So we're gonna see that timeout here somewhere. Where is it? Yes. Here, so he's trying to send the request outside. It tried to identify the protocol and then went timeout. I believe it is because I set to info. I need to change. I need to increase it even more. Probably debug. This is why. Let me see.
You mean to see
like
what? Oh, never mind. Go ahead.
So go here, and then I go the opposite. So what I'm doing is changing the log level of Linkerd, keeping the info, and change the Linkerd HTTP detect to debug and the up outbound to debug. And this is basically just gonna change the logs of the verbosity of the logs. Mm-hmm. Now let's try to send another request. And there we go. Oops. There we go. Because we will also see a detect. Okay.
There we go. That 15 seconds felt a lot quicker because we knew it was going to work.
Yes. Detect. We're actually showing a lot of stuff, and that's the one that we care. Is in debug. This is why we couldn't see earlier, but it's trying to detecting, and then read the timeout, which means it tried to understand the protocol. The protocol was HTTP1 or was HTTP2, and then tried to understand it for 10 seconds, and then give up, and then handle STCP.
Cool.
Actually, that's not much about protocol detection. That's the main thing. You can actually see some logs as well if we check the matrix. So if you do like this, we can see here that bound protocol detection. We can see the sum, how much time it took. So if you can start seeing some spikes, that's definitely something that is a warning.
Yeah, that makes sense.
But yeah, we can actually create some nice Grafana dashboard with average, and if it takes longer, that's a warning.
Cool.
Yeah.
Well, I think that's probably a good note to wrap it up.
Yes.
Thanks very much. There's a bunch of stuff in here that was really informative. It's always fun for me to come into these and walk away going like, oh, this is cool. I learned something. So yeah, many thanks to Ivan. I believe that we will be seeing Ivan again on June 18th. You're doing this one, right?
I think so.
Yeah. You know, we plan all this stuff so much. Let me put that up again. To sign up for that one, you will go to, not that, buoyant.io/SMA. Yes. If you go to buoyant.io/SMA, you'll have the option to register for, what comes after. Now what do I do? Nginx is gone. We hope to see you all there. Anything that you wanted to add, Ivan? Or
No, actually, that's gonna be a fun one as well.
it
It's
should
gonna
be,
very
yeah.
fun.
Yeah, I will not be here for that one, so somebody else will be emceeing, and yeah, have fun with it. I'll have to check the video out afterwards. All right. Well, thanks everybody for checking us out, and we will see y'all again next time. Thank
And
you.
happy removal of network policies.
No. Happy debugging.
It's gonna hunt you.